Water treatment is the set of physical-chemical processes to which water is submitted to change its properties, aiming at a specific application. The treatment process depends on the initial water quality and the degree of purity desired, and it is of great importance to prevent waterborne disease transmission. The treatment steps used may be different depending, mainly, on the characteristics of the water. In a conventional treatment, after water capture, aeration or pre-chlorination is the first treatment step and consists of causing the exchange of gases and volatile substances between water and air, in order to obtain a satisfactory balance for the levels of these impurities. At this stage, excess dissolved gases, such as carbon dioxide, hydrogen sulfide, volatile aromatic substances and excess chlorine are removed from the water. With the introduction of oxygen into the water, there will be also oxidation of ferrous compounds or manganese or increase of dissolved oxygen and nitrogen in the water. The next stage of treatment is coagulation. In this stage, clots are formed through the reaction of the coagulant with water. Impurities present in water are, predominantly, colloids that have a negative charge. Aluminum sulfate is one of the most used coagulants and causes coagulation through the adsorption of species originated from the hydrolysis of the coagulant on colloids that are responsible for turbidity and color in water. It causes a destabilization of these colloids, and this is called coagulation by adsorption destabilization. The reaction time is less than 1 second, and great agitation and a short contact time must be used. Another possibility is that coagulation occurs through the entrainment of particles formed by aluminum hydroxide. This is called sweeping coagulation. Reactions take about 1 to 7 seconds, and a longer contact time should be used. To keep the pH of the water in the desirable range for coagulation and to neutralize the sulfuric acid formed in the coagulant reaction, calcium hydroxide is added to promote and maintain the alkalinity of the water. To achieve the necessary agitation for the process, partial gutter or mechanical agitation are generally used. After coagulation, flocculation occurs, and, at this stage, the particles are forced to move so that they are attracted to each other, forming flakes. During this step, agitation is reduced in order to prevent the flakes from breaking. After flocculation, water remains in the decanter for about 1 hour and the flakes may settle by gravity, causing the water to clarify. Smaller solids that cannot settle can be removed in sand filters with gravel bottoms after decantation. Filters generally have 0.15 to 0.30 meters of sand layer height, 0.45 to 0.70 meters height of anthracite layer, 0.30 to 0.55 meters gravel layer height. The next step of treatment is chlorination, which consists of adding highly oxidizing chlorinated compounds to water, like chlorine, hypochlorous acid and sodium hypochlorite, and is then carried out to disinfect water, oxidize inorganic matter and organic materials present. The chlorine demand, that is the amount of chlorine needed for disinfection, depends on the levels of reducing compounds in the water, that can be organic and inorganic, the chlorine evaporation needed to obtain the desired disinfection results, and the contact time needed to obtain the desired effects. During this step, there will be the formation of hypochlorous acid and hypochlorite ion, that is called free residual chlorine. At the end of the treatment, the free residual chlorine content, hypochlorous acid and hypochlorite ion, in the treated water must be between 0.5 and 1 mg per liter. After chlorination, fluoridation is carried out, which consists of the application of fluoride products in the water supply to reduce the incidence of caries in the population. 0.7 to 0.8 mg per liter of fluoride reduces the incidence of caries from 30 to 50%. pH adjustment is also performed to reduce corrosion in pipelines. After the treatment, the water leaves the treatment plant and goes to reservoirs to be distributed to the population. If you liked the video, leave your like, and don't forget to subscribe, so we can make more videos like this for you.